In today's lecture, we'll discuss about microprocessing and computer architecture topic, advanced multiprocessor and architecture. Introduction to advanced multiprocessor and architecture. Multiprocessor architecture are designed to improve the communication performance by allowing the multiprocessor to work together in a single core CPU, reach their performance limits, but in advanced multiprocessor architecture have become a dominant method to enhance the performance, the power, and enabling the higher performance. Multiprocessor systems come in a various forms, including multi-core processor, semantic multiprocessor, and a massive parallel system. Key type of multiprocessor and architecture. First is a symmetric multiprocessor, SMP. Second, asymmetric multiprocessor, AMP. Third, distributed shared memory, DSM. Fourth, non-uniform memory access, NUMA. Fifth, massively parallel processing, MPP. And sixth is a cluster-based system. We will discuss today's lecture briefly about all of the topics and the advantage of all processor and the challenges that we will face to use this processor. First is a symmetric multiprocessor, SMP. In SMP, multiple identical processors are connected to a single shared memory, and each processor has its equal access to the memory and IO device, and they work cooperatively to the same task. SMP is commonly found in a modern multicore processor and servers. Key feature of SMP: uniform memory access. Memory access time is uniform across the all processors. Shared memory model. All processors have access the same memory space, allowing the easy communication. And third is a cache coherence. Since all processors share same memory, coherence protocol ensure that each processor has most up-to-date data in its own cache. The challenges and advantages. Advantages. First is simplify the programming due to the single memory space. Effective for applications that require tight communication between the processors. And the challenges are memory bandwidth become a bottleneck as the number of processors increase. Scalability is limited due to the shared memory connection. Second is asymmetric multiprocessor. In AMP, processors do not have equal access to the memory and IO device. Typically, the master controls the system against the task and the other processor which only execute the task without controlling the resource allocation. Asymmetric processor key feature. Master slave model. One processor controls the whole system while other execute the task. Dedicated workload. Certain processor may be dedicated to the specific task like handling I/O operation and background processing. The advantages and challenges while using the asymmetric multiprocessor. Advantages. Efficient for the system that perform the specific repetitive task that embedded engineering. In the simple hardware design, then the SMP. Challenges. Not ideally the general purpose communication, poor scalability, and load balancing due to the dependency of the master processor. Distributed shared memory. Distributed shared memory system allows the physically distribution processor to the shared memory, common the logically memory space. The memory is spread across the multiple nodes and the software or a hardware maintains the coherence between this distributed memory region. The key feature of DSM, logically shared memory. Physically distributed memory is treated as a single address space. Memory core. Protocol ensure that the challenges to a memory are pro- propagated across the distributed system. Low latency. Local memory access is fast, but remote memory access can be slower. The advantages and challenges while using the DSM. The advantages. Scalability is improved comparatively to SMP. The DMS allow the combination of both shared memory and distributed system benefit. The challenges: higher complexity, maintenance coherence between the distributed memory segment. Increase the latency when the access the remote memory. Fourth is non-uniform memory access NUMA. In NUMA is the multiprocessor architecture where each processor has its own local memory and access time depends whether the processor access local or a remote memory. This architecture is commonly used in a system with a multiple core processor CPUs. Key feature of NUMA: local versus remote memory processor. Processor have the faster access to the local memory and the slower access to the associated. with other processor, interconnected network. In efficient interconnect links, processor and memory ensure the fast data transfers, memory efficiently. Scheduling the processor close the memory they access the most frequently is the key to the NUMA performance. Advantages of NUMA scale better than SMP as the each processor has its own local memory and reducing the contention, providing the both high memory bandwidth and reduce the memory access latency for the local memory. Challenges in NUMA requires NUMA aware operating system and the application to optimize the memory placement. Insufficient memory access to the pattern can lead to a significant perform penalties, like example using of the remote memory access frequently. Fifth is the massively parallel processing (MPP). Massively parallel processing system consists of a hundred of thousands of independent processors, each with its own local memory and I/O resource. These processors communicates through a high-speed interconnection and work on a different part of a task in a parallel. The key feature of MPP is distributed memory. Each processor has its own memory with no global shared memory. Parallelism. Each processor works in a different portion of a program with a minimal communication. And third is a interconnection network. Efficient interconnection such as a mesh or a hypercube topology facilitate the processor to the communication. The advantages of MPP. Highly scalable, allowing for a thousand of processor work simultaneously in a large scale program. Excellent for a data intensive task such as a scientific simulation or a large scale communication. Challenges while using the MPP. Programming complexity due to the need of the distributed algorithm. High cost in a maintaining and managing the massive number of processes. Six is a cluster-based system. Cluster-based system consists of a multiple independent computers that work together to solve the problem. Each node in a cluster is a complete system with its own processor, memories, and storage. The nodes are connected via high-speed network. Cluster-based systems key feature: distributed community. Each node processor a portion of a problem. Inter-node communication. Nodes communicate via message passing, typically using framework like MPO, message passing interface. Redundancy and fault tolerance. Cluster often incorporate redundancy, allowing the system to continue work even if one node is failed. The advantage of cluster-based system is highly cost-effective comparable to the specialized computer. Can scale horizontally by adding more and more nodes on a cluster, suitable a wide range of applications and from the web service to the scientific computation. In specifically web service, they are mostly use cluster-based system because if one part of website is not working properly, then the whole website will not be crashed. Therefore, they are using cluster-based system. The challenges: network latency, bandwidth can become a bottleneck. Require the sophisticated software for a job scheduling, local balancing, and a fault tolerance. The conclusion of today's lecture is advanced multiprocessor architecture are critical for achieving the high-speed communication performance, scalability, and efficiency in a modern system. From SMP with a shared memory to the massively parallel system with thousands of processors, these architectures are unable to faster execution of complex tasks by leveraging the parallelism. However, the challenges such as a cache coherence, memory consistency, and the efficient inter-processor communication require a sophisticated design and a programming strategy to fully harness the power of multiprocessor. In generally, we will use the processor according to our requirement, which task we should be done by the computer. Thank you.